Hey guys, Jimmy Song here, off chain. I wanted to talk about Mempool and Segwit in particular and how Segwit would help relieve mempool congestion. I have this graph up. This is the current state of the mempool. There's sort of three ways to look at it. The first is just like the number of unconfirmed transactions at each level. It doesn't really tell you how big each transaction is, but you can see that we had some really high fees and people paying some ridiculous amounts for various transactions. And we started getting some relief, and then we started going up again as some of the lower fee transactions started showing up again after getting kicked out of the mempool. You can see here, this is a pending transaction fee in BTC. It was really high, and a lot of miners made a lot of money off of it. But we've more or less stayed steady or going down a little bit in the last couple of days, which is great. The actual mempool size is over 500 or a couple hundred megabytes here, and some of the blue ones that existed, it got kicked out because they were too low a fee. Yeah, the blue area is like 1 to 2 Satoshi per byte, which is really low. Anyway, I wanted to talk about how Segwit can sort of help relieve this, and let's talk about that a little bit. So this is from my programming blockchain course, and here is what a native Segwit transaction. This is spending from what you would call a Bec32 address, which isn't very common right now, but this is native Segwit. This is what a native Segwit transaction without any of the witness data looks like. This is stripped of witness data. This is what it looks like, and it's not very big. It's actually quite small if you think about it. It's I think less than 100 bytes or something like that, and this factors into the calculation for how blocks are validated. It has to have under 4 million block weight. Versus 1 million block size, which is what it was before Segwit. But yeah, this is what it looks like, sort of stripped of witness data. And that, by the way, is what's sent to non-upgraded nodes, or before 0.14. This is what a normal transaction. This is a pay-to-pub key hash, or addresses that start from 1. If you're spending from those, this is more or less what it looks like. You see that big yellow part. It's a lot bigger than this one, which is 1 byte of that yellow part versus like 100 bytes of that yellow part. So you can see that it's smaller. As far as actual upgraded nodes, or what the actual transaction looks like, this is what the actual transaction looks like. That yellow part sort of has gone over into this, I don't know what color to call this, like maroon part. You can see that a lot of the same data that was in the yellow part is now in the maroon part, and this is what you call the witness program, and this is what's sent to upgraded nodes. This is these are the actual transactions, so this is what's calculated for actual block size. Anyway, so block weight is calculated this way. You take 3 times the transaction without witness data, plus the size of the transaction with the witness data. So more or less, the witness program part gets counted like as 1/4 of the rest of it, and that's more or less how you can reduce the actual weight, but have a larger size, right? And if you sort of have everybody in the network utilize native Segwit, I think the optimum comes out to be about 2 megabytes in size, despite being 4 million in weight. Again, weight is the big calculation, and you can see that the size varies all over the place, but the weight always stays under 4 million because that's the new restriction that's there. And this is where Segwit as a block size increase comes from. And this one has like 15% bigger block than before, and Slush Pool tends to mine more Segwit transactions as a result. But that's more or less how you can actually like reduce or put more transactions into a block is by utilizing Segwit transactions. Now, this is native Segwit, and actually there's another type. It's called pay to script hash, pay to witness, pubkey hash, or nested Segwit. And this is the Segwit that most people use. These start with a 3. They look like pay to script hash, starting with a 3. And you can see that the yellow part is still smaller than pay to pubkey hash, but it's still, it's got like 23 bytes or something like that. So it's backwards compatible, which is nice, but at the same time there's still a substantial yellow part. And the pay to script hash, pay to witness pubkey hash, it contains the witness program. So you take 3 times the size of this thing plus the size of this thing, and that's your new that's the weight of the transaction that you utilize. And we're using mostly this, but eventually we want to get more to the Bec32 addresses. Unfortunately, not a lot of wallets support that, though. I think a lot of wallets know how to sort of parse it, or block explorers might know how to parse it, but it's actually not utilized by wallets or services very much. Even pay to script hash, pay to witness pubkey hash isn't utilized by companies like Coinbase. Again, they're sort of built on technology from 2013, which were big transactions like this. They're not taking advantage of Segwit, if you will, and they can reduce their costs massively if they did. Instead, they're passing it on to their customers, which is quite a bit unfortunate. All right, so anyway, I did write a couple of articles regarding this. This is Understanding Segwit Block Size. This talks about actual calculation. Here's that calculation: TX size with witness data stripped times 3 plus TX size. And there's another article I wrote, Understanding Segregated Witness. This isn't quite as technical. It just sort of explains what's going on and making the box bigger and stuff like that. But hopefully this helps you understand why Segwit would help even just on-chain scaling. Because if you utilize it more, then you can have more, you can fit more transactions in the same amount of weight. And that's not even mentioning like Lightning and stuff like that. One of the things that's really nice is that the transaction ID is taken with the witness data strip, so there's no malleability vector. The signature is in the witness program. In a pay to pubkey hash, it's within the script sig, that big yellow part here. So anyway, you can take a look at all of the stuff that's going on here, and you can see that it's not you can't malleate it, so it lets you do the funding transaction, which helps payment channels, which eventually leads to better Lightning network. Anyway, hopefully this helped you understand how Segwit can be utilized to fit more transactions into a block and thus sort of reduce this giant mempool that we have. Anyway, thank you very much, and this song is done.